back once again. Welcome. So here's my input shaft, and as you can see, since the last video I've saved it. So make sure you save your work. Now, as I said, this feature here is where the gear is going to go, and we need to stop it from rotating, so we can insert something called a key. Okay, that's a lozenge shaped piece of steel that drops into a lozenge shaped hole on the shaft, and then you have a slot cut into the hole of the gear so it can slide over that key, and it'll help transmit the forces, or rather the torque. So let's have a look at how we might go about doing that. So let's have a look on this PDF. So I've put this PDF on Brightspace for you. So this is all about metric keys and keyways, and it's BS 4235 Part 1 1972. So they've been doing this for a long time, okay, and we still do it now. This is the way you do it. Some materials, don't need to worry about it, just have a look at this. Free, we don't want it to slide over. Normal, yeah, that sounds alright, doesn't it? That's the type of fit we want. We want a normal fit, so we just need to make sure we remember that as we scroll down. Here's the dimensions of basically the holes that we need to drop in there. Okay, so this is the depth of the hole, T1, we just need to remember that, and B is the breadth. Let's have a look. Here we go. So the width B, that's nominal. Here's the diameters of the shaft. Now my shaft diameter was, if I can remember, 14. So between 12 and 17. That's my diameter there. So I need a 5x5 key. That's not the length, that's just the square section, 5x5. And for a normal fit, on the shaft I need an N6 tolerance. Sorry, an N9, what am I talking about? N9. So that gives you between 0 and 30 microns undersized. So, and on the gear, that's the hub, the gear, it can be plus or minus 15 microns. So let's have a look at the depth of the cut that we need into the shaft. Nominally, we need a 3mm deep hole, essentially, plus 0.1 minus 0. So it's probably easier if we make the hole depth 3.05, then we can have plus or minus 0.05. What that means is we can have a 0.1mm profile tolerance on the depth of the hole. That makes it a lot easier to dimension that feature on the shaft itself. Okay, so we're going to split that tolerance instead, so it'll be 3.05 deep hole and 5mm wide, and then we just need to set the length. And as you can see, somewhere on here it tells you which table you need for typical lengths. It doesn't say on there, but I happen to know that it's table 9, not 8, not 8, table 9. These are typical lengths, so these are preferred lengths. Okay, so you wouldn't want a 17 or a 15mm length of key because it wouldn't work. So we'll probably put a 14mm key in that slot, or maybe a 12. But we'll look at it in a minute. So we're going to put a hole, a keyway of 14mm, let's say, in our shaft. So just click up. And there's our stat. This is what the key looks like. You see, so it's lozenge shape. And it just drops in. And it just needs a little chamfer on the edge. And L is the overall length, not the distance between centres, but the overall length. So we'll have a 14mm long slot. So let's go back to SolidWorks. And we will go to our input shaft, and what we need to do is set up some planes. So the first thing is, let's turn on the top plane so that we can see it. There we go, top plane is turned on, and that bisects the shaft. Now at some point you might change the size of this, so you don't want to measure directly off this surface, but you want to measure off the top of here. So we need to set another plane up parallel with this one and sitting on this one. So features, reference geometry plane. First reference is going to be this plane. Second reference is going to be the cylinder. Now you see how it's trying to put it perpendicular. We don't want it perpendicular. Here's the perpendicular setting. We want it parallel, like so. And we click OK. Now we can turn off our top plane. We don't need that anymore. And here's our new plane that we're going to sketch onto. So sketch, sketch, and we'll pick up that plane. If I hit the space bar, I can go normal to it. So you can see now that our origin sits the middle, doesn't it? Remember when we built the shaft, we said put the origin in the center of that segment. Just as well I did, because this makes life really easy. Now here's some slot settings. This is the one we want, center point, straight slot. Here we go. And what we also want is not this setting, but this setting, overall length. There we go. So we'll just click on there, drag up, click, drag out, click. It's as easy as that. Okay. Now we need to dimension it, otherwise it's not going to be the right size. So we need to set a width. And I believe that needed to be 5, didn't it? So let's make that 5. And then we need an overall length. So watch out. There we go. And this needed to be 14. There we go. And obviously it depends on the actual diameter that you have here for your gear. You don't want this diameter too small if you've got a really big gear, okay, because it will just have too much torque going through it and it will just twist off, and it's just rubbish, essentially. Right, that's the technical term anyway. So there's my slot. I'm going to extrude cut that. Features, extrude cut. Now if we remember, the default is 3 plus 0.1 minus 0. We don't want it to be plus 0.1 minus 0. We want to go half. We want to extrude this midway through that tolerance zone. So 3.05. And it'll be different for everybody's because it depends on the size of your shaft as to the size of your hole. That's it. And we'll click OK. And there's the slot done. Okay. Everybody happy? Thought so. Right, at that point you can probably just turn that plane off. Don't delete the plane and don't suppress the plane. Just switch it off. And I'm just going to swing this round so it's dimetric. There we go. What a lovely job.